Good afternoon, everyone. My name is Joseph Bakarji. I'm a professor in mechanical engineering and AI Hub. And it's my great pleasure to welcome today's speaker, Sherif Maktabi, who happens to be not only an award-winning AI product leader at Amazon, but also a very dear friend. So Sherif and I met 16 years ago in a physics lab, Physics 211, of all places, where we had to take measurements from an oscilloscope and perform linear regression by hand. And our paths soon diverged professionally, while I delved deeper into theoretical methods for scientific research. Sherif actually chose a path focused on creating functional and elegant products that enhance our everyday lives. So 16 years later, our paths intersect again around regression, but now it's not by hand, and it's billions of times more fitting parameters to deal with. So in the past few years, Sherif defined the AI strategy at Amazon stores and founded an AI tech team, delivering more than $200 million in incremental revenue from scaling AI-driven products. Most recently, Sherif built Amazon's largest AI agent, used by 300,000 employees worldwide. And his insights into the commercial and strategic deployment of AI have set standards across the industry in agentic AI systems. Today, Sherif will share the lessons he learned from applying AI at scale and the challenges faced by emerging AI technologies, and most excitingly, his vision of what lies ahead of large language models and the broader landscape of AI. So Sherif, thank you so much for being here. We're very excited to hear your story, and please take it away.
Thank you so much, Joe. This is a very humbling and personally meaningful introduction. It's true, we met literally for the first time in a physics lab, maybe like 5 minutes walk from here, so it's very nice to be back. All right, talking even more about me. After leaving AUB, it's been quite a ride. I worked in a small startup where we built computers for kids to learn how to code and build their own computer. I also joined the Michelin group, where I helped them pivot to focus on building software for electric vehicles, where we helped some of the largest companies in Europe to move to electric and manage them and optimize them. And then most recently, as you can see from the banana, I was at Amazon, where, as Joe said, I did a lot of work in AI and helped build some really exciting things. And I have not forgotten where I come from, which is a place that is very near us. These are the only photos I've been able to find from the Facebook archives. I had to scroll a lot to find some of these, but this is being in Mech 200, which I think very fondly of. So I'm going to talk about 3 things today. We're going to talk about AI. We're going to talk about scaling AI, and third, some of the lessons along the way. Hopefully, at the end, we'll try to make some time for some questions, if we do. When I first started, the moment we in the ChatGPT moment, I thought, this innovation in large language models is probably going to be somewhere along the scale of, in terms of impact, of the iPhone or the internet. So it's going to be, either that big or that small. And I now have a different opinion. I now think that AI is as significant of a discovery as fire, and the impact that has had to our civilization. I think that AI is going to have that too. So my goal out of today is to basically convince you that it is as important as fire, and to go all into AI, to really take this as the biggest thing that is happening in technology. This is it's been like over 2 years and 3 months since ChatGPT launched, but I still think it's day one for this technology. My favorite analogy is to actually put ChatGPT and the first browser next to each other, because the first browser did almost the same thing that ChatGPT did, which is it took a technology that exists and it made it easy for anyone to use. And that browser is why there's been such a huge revolution in internet technologies and the impact on our daily life. ChatGPT does the same thing. But at one point, we're going to look back at ChatGPT, and we're going to feel it's as archaic and as old as this browser from like the early 90s looks like. And to make my point even clearer, ChatGPT is the fastest growing commercial application in history. It's faster than Instagram, faster than Spotify, faster than Netflix. And then if you zoom back, AI technology is 5 times faster in terms of adoption and diffusion into society than the internet itself. It's faster than the PC, it's faster than electricity, and it has a lot of these attributes of a technology that diffuses and changes the world that we live in. So, but what is different with this technology is that it's about intelligence. And so if you plot, IQ, average IQ over time, in the blue line you see the IQ of human beings improving over time, and the red line is LLMs. And this is now outdated. It's been updated in 2024, I think, with the new models that are coming out. It's just strikingly fast and intense. This is another evaluation, eval, for software development. When LLMs started being evaluated on this benchmark, they were able to solve around, less than 5% of some of the hardest coding challenges that are available publicly. The last time this was measured, it's around 53%, and it's basically growing linearly. We expect it to be at 90% at the end of this year. The reason I'm showing these evaluations, and I'll talk about this one, is that what we're learning about LLMs is that when they're able to develop new features, there are also other intelligent features that emerge by happenstance. So this is another eval, which is essentially a graduate level Q&A. And you can see that the blue line is essentially how good a human PhD with Google is able to achieve using this evaluation or this exam. And O3 from OpenAI has beat basically human PhDs who also using Google. So they're getting so good, these models, that we're having to invent new ways to evaluate them. So most recently, Scale AI launched this paper. It's called Humanity's Last Exam. And essentially, they got the best professors and PhDs and experts from every single domain. And they told them, please come up with the hardest problem you can imagine. And some of these are like, here's this representation of Roman inscription found on a tombstone. Help us figure out what it is, or some biology or ecology. And LLMs are already starting to like grab and grow up on this evaluation. And you can see at the bottom, OpenAI's deep research, which is a feature that was launched in January, is already at 26%. What's different and what is unique about deep research is that it's not just an LLM, it's not just Q&A, it is an agent. And a lot of what we're going to talk about today is about agents. So all of this is happening, the improvement in performance, improvement in intelligence, diffusion into society, while cost is dropping extremely quickly. So between 2023 and 2024, you can see output tokens per million output tokens drop from $60 to $10, which is 6x. And this is going to continue trending towards zero. So I have the strong intuition that this is as significant as fire. This is happening extremely quickly. It's going to make intelligence cost zero and expertise cost near zero. It's going to have a significant impact on our life. I would even go further and say that the AI future is already here, but it's just not equally distributed. It's not everywhere for everyone at the same time. And because of the type of technology this is and how it diffuses in society, every single technology like this goes through this hype cycle, the Gartner hype cycle. And basically, what happens is there's a technology trigger, ChatGPT comes out, everyone's like, this is going to change the world. And then they realize it makes mistakes, peak of inflated expectations, everyone drops, they're like, this is just a joke. And then there's this moment of enlightenment where people realize, aha, this is what this is going to do. This is where I can use it. And then there's the steep slope of productivity. This doesn't describe the technology. This describes human behavior. And so we have to ask ourselves as people, teams, organizations, where do we think we are on this curve? and help ourselves get as much as possible to this black dot of enlightenment as fast as we can. The industry is also saying some extreme things. I'll share what the CEO of Microsoft AI says in a recent TED Talk. He said, AI is going to be a new species. The CTO of Amazon says, AI makes predictions, just a tool, don't worry, we're going to be safe, we're going to be fine. But a good quote is from Jensen Huang at the end, which is, AI won't replace you, but someone using AI will, so you better get on the train, basically, as fast as you can. So I'll share some examples of how the AI futures are here. These are screenshots from full-fledged movies that were made from a single sentence, single prompt sentence from Sora. This came out in last year. This is a screen grab of me building a website for this timer that I showed you before. And all I did is build a website that shows the time since ChatGPT was built. And here I'm saying, okay, change everything to dark mode. So I didn't write any code, and this you can actually visit the website on timesince-chat.com. And I just clicked enter, just a few sentences here. And this tool called V0 is going to go in, change all the code, and you'll get a dark version of this website. V0 also launched maybe 6 months, 9 months ago, I think. So I'll just wait for this to... There we go. This is an agent from OpenAI. It's called Operator. You can ask it things like book me flights or book like a trip to Rome, and it'll go and use the internet. It has its own computer, it has its own browser, and the LLM is gonna basically figure out what you need and book it for you, do work for you. This launched in January. This is my favorite example to really make this idea that the future is already here. This is an agent called, from a paper called ChemCrow that came out in December 2023, so over a year ago, over maybe almost 2 years ago, where they were the first to really show this agent architecture, where an agent can basically design an experiment, become an expert on a bunch of science domains, write code for the machine in the lab, which you can see the picture over there, run the experiment, collect all the inputs, and write a paper. And in their paper, they actually say how this agent autonomously was able to synthesize new insect repellents and find and discover a novel chromophore. So this was December 2023. This is old, is what I'm saying. And so these agents have this kind of architecture where the agent uses things that feel almost very human, right? Like they have memory, short-term and long-term memory. They have tools, access to tools via, if you're familiar with Anthropic tool use. They can plan, so they can reflect, they can have chain of thought, they can reason, and then they take action on the real world. And there's already a very, very mature ecosystem to build, deploy, launch, evaluate, test agents. Everything from cloud services to specific science applications. Even the one that I used called V0, you can already use it today. So to kind of set this in context of where we are, this is a table that I kind of hobbled together from a bunch of people who try to predict the world of AI. So this is not like my creation, just me trying to summarize things. Basically, if you just imagine how people think of autonomous vehicles, like an L0 autonomous vehicle is you drive. L1 is, it tells you sometimes when someone's behind you. L2 is, it can make sure that you stay in the lane. L3 is, it makes sure that you can stay in the lane and can drive the speed fast forward and backwards. L4 is, it can drive on its own, but only in highways, only between Beirut and Saida. L5 is, it can drive anywhere, all over the world. And so agents or LLMs or this technology, you can think of it kind of in the same way, where we were in the era of chatbots. We moved to the workflow era where people are doing massive scale applications, and now we're at agents. And agents is still restricted to a domain, still has some level of ambiguity, not a lot of ambiguity, and not a lot of cycles or really, really long-term planning. But what will come is going to be way more significant. Specifically, the L5 agents are expected to essentially replace full-blown organizations. that they will be able to do the work and the output of companies on their own. So I'm going to share now, this is the section where it gets a little bit more technical. We're going to talk a little bit about some of our learnings from launching these very large-scale AI applications in my career so far. I can't talk specifically about what I've worked on because of confidentiality, but these are some of the things that are publicly released by Amazon. So it's two different areas. One is called the Amazon Q. Amazon Q is a conversational AI agent. It can do everything from write code into your code base to find information about your business and respond to questions, help you forecast business. And then on the right-hand side is Amazon stores where basically every single product page can be personalized using LLMs. We help sellers basically from sharing a URL of a product to selling the whole product on Amazon without them having to do a lot of effort. So these are two very different areas. So some of the lessons I'm sharing are related to these already publicly available innovations. And I've worked in these two separate domains. I thought it would be helpful to kind of categorize them into 6 separate lessons or challenges. We're going to talk about each one. The first one is there's a speed, scale, skill trade-off. We're going to talk about the eval as a new paradigm, relying on humans. RAG is hard. Can someone raise their hand if they've built RAG or they built an LLM that uses RAG? Okay, great. So RAG is retrieval augmented generation. It just helps an LLM kind of get some knowledge that it doesn't have from training. We're going to talk about agents and how they're even harder than RAG if you've underestimated RAG. And then lastly is hopefully I'll convince you to not bet against LLMs, especially not bet against them getting even better. So this is my favorite lesson that I've learned, is that when you're building a large-scale AI application, there's a trade-off that you actually don't see until you get into the weeds, which is there's a bunch of strategic decisions that you're going to have to take. One of them is essentially picking your layer of abstraction. So this is the services from AWS. You can go all the way down from running your own training on hardware all the way up to Bedrock, where they offer you an API for inferencing. But then you can go even higher in abstraction, where they offer you Amazon Q, where you just drag and drop, click, and you get an SDK if you want to customize it to have your own agent. So this strategic choice about where you're going to live on this abstraction influences a lot the long-term outcome and actually what's going to happen with your application. So I made this 2x2 to kind of make my point, is that if you are going to choose more abstraction, you're actually going to become slower and slower and slower over time. The reason for that is that you're going to have to wait for the abstraction layer to adopt a technology that the layer below it has to adopt, that the layer below that has to actually use. And so when there's something new, like a new model, you're going to be lagging behind because you've chosen some level of abstraction. There's other issues, but that's one of them. And so if you have a team that's actually not skilled in building AI application, you're going to have to choose abstraction. And so you end up trapped. So that's why at the top left corner, this high speed or fast with less abstraction is very talented teams tend to really use and be very, very flexible in how they build their applications. If you're using less abstractions, you're kind of going your own way and it's going slow, you probably have a very ambitious prototype that you're trying to build. And so there's a lot of learning, obviously. And what happens as well is the people who are choosing a lot of abstraction and they finally end up in the slow state is actually enterprises. It's kind of like an enterprise trap where they need to optimize for safety, they need to optimize for services that take care of a lot of things for them. And so they're stuck in a trap where they're going to be slower than their competitors. There's another new paradigm, which is evals. Evals is kind of the way where you're trying to figure out if the LLM or the application is working or not working the way you want it. In software development, it's kind of like testing a train. You have these software testing that's very straightforward. It starts one place, it ends in another place. You can chunk it up into stages. You have integration tests, etc. And it's very sequential. Testing or evaluating LLMs or AI applications is kind of like you're trying to test a city. It's non-deterministic. You don't know how it's going to behave at the edges. It's very different. It's very strange. So you need to change your paradigm of trying to figure out if what you're building actually works or not. And evals, or evaluations, are the most important tool for you to have a data-driven decision-making in building a very large-scale AI application. If you're not able to design or define your eval and use it to actually evaluate the system that you're building over time, and change your mind that this is not a deterministic system. It's non-deterministic, which means that just like a human being, if you ask me 100 times the same question, I'm not gonna give you 100 times the same answer. And so you need to kind of move to a world of evals where you're able to also scale the way you're testing, especially when you're growing to very large scale applications. The last, not the last, but another lesson that we've seen is people are building these AI systems, and in the system somewhere, there's relying on human beings. Like, here's an example. There's this beautiful diagram of, you get data, you put the data somewhere, an AI model looks at it, does some output, and there's this human verification. Human verification is the enemy of, or human involvement or human in the loop is actually the enemy of scale. I would go so far to say if a human is involved in your large-scale application, it's not scaled at all. Because when you're scaling, you have to look at your unit economics. Your inference costs, especially when you move into agents, are extremely higher than if you're building a chatbot. And so if you're building an AI app, you need to look at your unit economics, and you need to look at if you're still actually not finished building because you're still relying on humans somewhere. Like, there's still a human in the loop. This is also non-obvious because when we started in the world of AI, there's a lot of, essentially what happened is popularization of concepts like pre-training. You need a lot of data, you need a lot of scale, human reinforcement learning via human feedback. The state of the art has moved on from RLHF, or human feedback. That's no longer something people are doing. And so humans should not be part of your scaling plan. Lastly is don't bet against LLMs. Actually, I drew a very similar meme for my own team because we did like a lot of debates where we'd have this like very, very clear use case. We want to build this AI-powered use case. And engineers have this intuition that, okay, here's the system. This part's going to do this part's going to do that. And actually what we found out is that if we just waited like a month, LLMs are going to get better enough that the system is just way smaller and it's just way cheaper and way quicker to do. And so try to avoid jumping into the hardest thing when you're building an AI application. You don't need to build an LLM. You don't need to fine tune. Start from the basics, start with prompts, start with prompt engineering, iterate, and bet on the fact that this technology is going to keep getting better and keep getting much, much quicker. And so there's a lot of times I've been in teams who have been trying, for example, in our region, they've spent billions of dollars trying to build LLMs from scratch that speak Arabic. I would say this is mostly unfortunate spend of money. As soon as you build that LLM, it's going to no longer be state-of-the-art. There's a lot of different ways to achieve your application, or just betting on the fact that these base models are going to keep getting much better than we think. RAG is hard. So RAG, by the way, for people who are like, this is what's RAG? LLMs are trained up to a certain point in time. And so when you ask them a question about something that happens afterwards, they don't know the answer. So they use a system like, which is called RAG, to get this knowledge. And so it also was popularized that, don't worry, LLMs, you just put RAG and it'll answer any question as long as the data source is available. Well, Sid.ai in 2024 released a paper saying that 68% of production queries in real life fail using normal RAG. That's more than half. It's a ridiculous amount of failure, basically. And what we found in building these systems is that, first of all, you have a data quality challenge. Like the documents, not all documents are created equal, not all data sets are created equal. Information density varies. when what you do in a demo doesn't actually look like what it looks like in real life. Then there's retrieval complexity. RAG relies on vector databases or embeddings, but generic search often beats using embeddings. So, and then when you want to use a hybrid approach, it's actually not that easy. And also the metrics you want to use to measure are not always the best, are actually very useful. Then there's this issue of context engineering, or basically managing the context length. Every LLM has a limit to the amount of tokens they can consume. And so what happens is you get, like for example, Anthropic recommends that you get 100 chunks or 100 passages to actually get a good retrieval response. But having hundreds of chunks every time and having a lot of context usage is going to really make it very difficult. So it's kind of like a system optimization challenge. And lastly is dealing with the fact that you have hallucination rates and that every time triggering or over-triggering RAG is going to reduce your latency, et cetera. So the good news is that there is a solution, or at least a bunch of solutions. One of them is using an agentic approach. So basically, and what you're going to learn from a lot of these examples is a lot of building an AI application is actually a lot of system engineering. So here what happens is you actually treat queries as like a wish list, and then you separate them between when you use an embedder and when you use a router who's able to capture more metadata to better answer and make a decision whether it's going to answer you or not. So the performance here is significantly improved, and you can learn more about it in the SID AI. So now we're going to talk about autonomous agents. This is a great paper that I recommend reading, but one of the main points that they say is actually just simple retries will beat state-of-the-art agents. And there's a reason for that, which we'll talk about. But basically, agents have problems. Because agents use the LLMs that we also use for chatbots, they have this kind of tunnel vision where they're very eager to give you a response. They're very eager to make progress. And they don't have the intuition to first like ask assumption, figure out the assumptions, try to ask you questions more before they jump in. The second is that they are based on things that still lack the performance we really need. So they don't have knowledge that is specialized in your domain. They still have weak models that are not trained on very long-term tasks. And then you also have the problem of no ground truth. No ground truth means that when you're using an agent for a bunch of tasks, the task domain that you're actually working in is very unique. And so coming up with your own metrics is very hard. And if you just want to use benchmarks, like from all the leading benchmarks, only 5 out of the 17 today are actually relevant for agents. So there's a lot of opportunity for research and discovering how do we adapt what we've been using for standard LLM to the world of agents. Lastly, it's extremely more expensive. For example, on average, it costs something like $8,000 to just evaluate your agent. Retry volumes are very significant with agents, and you have a high trade-off between accuracy and cost. To give you an example of this cost, this is a logarithmic scale of relative cost and task versus task complexity. So the dotted line is actually like a human expert trying to do a task. And so you can see that to really beat humans, you need specialization and you need high performance. And those will require, as we're going to see later, a lot of retries, a lot of checkpointing. And so the cost really accelerates significantly. This is an optimization problem. The improvement of model performance is going to make a big difference. But this is generally also saying that there's a system engineering challenge with these applications. So these are some really interesting approaches to handle some of these problems. My favorite quote from the space is from someone from AWS that I got a chance to work with, who says, chunking, which is like chunking your tasks into chunks of tasks, and concurrency, which is running in parallel, is the currency for agents. So I highly recommend you check out Yasser Shaban at some point. He's an awesome guy. So on the left, you can see that basically using more chunking will help you, as in like split up your long-term task into smaller tasks. are gonna give you a higher probability of success. Which means that when you do a bunch of tasks, the LLM or the agent asks itself, okay, what have I done? What do I need to do differently? And on the right, it's concurrency. So you can see these curves actually show you that you have higher probability of success the more and more parallel attempts there are going on to solve a certain task. I know this is for some, this might be like a lot of me baffling around, but even if all of I'm showing so far just stops, right, and the LLMs just stay where they are, it's going to take us, this is a quote from a professor, I forgot to quote him, but I will. It's going to take us like 20 years just to digest all the impact from the existing LLMs and the existing technologies that we have so far. So I'm going to leave you with just a few things and wrap up, and maybe we can have a few questions, is that these technologies, which we just spoke about, how intelligence is improving and agents, and our ability to handle engineering these very complex applications, what they're going to do is they're going to collapse roles. That we tend to have this idea of these silos of people, people who do business and people who do engineering or design. What's going to happen is that these roles are going to start to collapse, where these agents and these LLMs are going to help us actually do a lot more from a single role. And once that happens, also team structures or the way we form organizations is going to change. So instead of having just a business division and all the marketing people together and all these people together, you're going to have much, much smaller teams that are highly talented and highly agile, and they're going to be able to do a lot more with a lot less. And lastly, on a positive note, that it's also going to give you superpowers that we're going to have very soon, and we already do, have the ability to do things outside of our imagination, to get expertise that we never thought we'd imagine. And it's going to help us do really incredible things. And so hopefully I got a chance to convince you to go all in on AI. And with that, I want to thank you all very much for spending this time with me so far. Thank you. I can't talk specifically about Amazon, but what I can tell you is the industry, or most industries, but firstly, the tech industry is going to face a really massive challenge with hiring and resourcing their teams. Originally, we thought the challenge is going to be that if you think of a tech company, you need like really talented engineers, like very senior engineers. And these agents are really good at replacing junior engineers, right? Like people who are maybe straight out of university. That was our assumption. But in practice, what we're realizing is that junior engineers or people who are still in university is actually much, much better at adopting and using AI as part of their work. And we're seeing some junior engineers actually produce better outputs from some of the senior engineers. But this is some of the positive side. But the real challenge is going to be that I think big companies are realizing that they don't need as many people as before. And this is going to have a big challenge on hiring. So I can't predict on what's going to happen, but we can already see layoffs happening in Meta, layoffs happening in different companies, and the bar being raised on tech talent.
So thank you so much for your talk. It's amazing. By the way, the website is not working, your website.
Okay, I'll ask my AI.
So what can't agents do? Like we should manage expectations, right? Like where is the bar here?
So right now, the state of the art in agents is very restricted amount of ambiguity, not a lot of depth in planning, and a domain that requires computers. This is kind of where like the state of the art is.
Yet no multimodality yet.
There is multimodality, and so what's happening now is that there's a lot of people working on like bringing it to robots in the real world. There are a lot of people working on very long-term plans and tasks, very deep tasks. There's a lot of people working on very specialized things in science. So I just showed you ChemCrow, which is like very specific. So there's a lot of work, right? But it's the development is happening very, very fast. So your question will have a different answer in like 3 months.
I want to ask you about like AI at scale, like in terms of sustainability, energy use. Obviously, AI is very energy hungry, and this question comes to mind. How do you manage that?
So there was like the main hypothesis or thesis that drove the development and the investments into AI is that it's called the scaling hypothesis, which means more data, more machines, more computing, which also means more energy. And you'll see like better intelligence, which means better outputs. DeepSeek and DeepSeek R1 proved that hypothesis wrong, basically, because they showed that if you use weaker machines and you use less machines, you can develop a model that's as good and sometimes better. And so the need is like the need of being able to innovate in scarcity is going to drive some of the energy savings. The challenge, the headwind to energy savings is the fact that we're investing way more than demand. And so inefficiencies in energy use is kind of where we are now.
Giving it the ultimate energy use and things like that does not help.
So like today, if you look at the world's energy is more used by non-humans than humans, right? Like the tech sphere, like all the factories and all the computers already use way more energy than us. And so we should expect this trend to continue. And there's a lot of innovation happening in like using the heat from these GPUs to do other things like filtering water and creating drinkable water and things like that. So there are things happening there.
As you said, the tech is already there, right? But to make the money, the product is to leverage that tech. So ChatGPT did the question answer thing. What do you think would be the next product on software as a service companies that will leverage this tech and like will do the hit?
You're asking me like a $1 billion question.
Yeah, do you have it?
I mean,
the answer?
like I can tell you that, for example, what I've learned is that distribution actually matters way more than like if you're using the state-of-the-art model or not. So if you have distribution where you can distribute your AI application, that is more likely going to lead to success than not. So for example, there's a lot of companies that have a lot of existing customers or a lot of, like if you think about Microsoft, like Microsoft has, there's Windows here, right? And so they can distribute AI applications massively, very, very quickly, and then capitalize on it. And so those players or people who have distribution and are able to quickly deploy are going to benefit a lot. And what's going to happen, and in terms of the actual AI application itself, what I'm seeing a lot of the trend now is people moving to enterprise and focus deeply in optimization and cost reduction for enterprises.
Hi. When do you think AI will start to rely on AI to learn instead of the human interaction and giving an input
that
from
already happened.
Sorry?
It already happened.
But it's relying at some point on the human input, correct?
No, not anymore.
100% based on AI?
Like now the state-of-the-art labs, like the frontier labs, don't use human feedback much. So if you look at DeepSeek R1, they published papers that showed you that they essentially use reinforcement learning, which is the kind of the LLM teaching itself, to get to the level of performance that they have. So what DeepSeek R1 kind of did is they uncovered the secret that the other frontiers labs did, and they just published it publicly. So for example, and this goes to the scaling question, is that there are people who are publishing papers now where they take like just 8,000 samples of math questions, and they're able to use RL to get a very small model to beat the state-of-the-art evals in math. And so we've moved on from using humans for, like relying solely on humans for this, probably at some point last year.
So back to your last chart that you were showing, that team's gonna be collaborated more. Yeah, something like this. It means that in terms of employees, they will tend more to have general knowledge from multiple things better than being focused on one path. For example, let's give an example of a data analyst. Let's say a data analyst will be focusing on analyzing data and creating dashboards and stuff like this. should they focus on this path, or we should be like having some general knowledge from everywhere so we fit whenever we there is a need? Because with the improvement of AI, there will be somewhere where a data analyst maybe, I don't know, something in between. So what do you think?
I'm conflicted about questions like this because part of me expects that, and so I'll describe this conflict. Part of me expects that essentially what will happen is because cost of expertise is going down and intelligence is going down, what matters is people who have other attributes like resilience and creativity and deep thought and ability to think very divergently, and also have very unique combination of skills or really world-class skills. And those people are gonna have to become very high in demand. And those are the type of people we wanna kind of train and create. And everyone else has to kind of upskill to become like those people. But my other side of the conflict is if you look at places like animation, animation used to be like hand-drawn animation, and then people made computers that can do animation. And everyone thought, okay, no more animators. But what actually happened is the bar for movies went up. Like we expected way better movies. And so we needed huge amount of animators who need to use way more skills. So I'm not very sure like which world we're gonna end up in. But it's going to definitely change.
But to be on the safe side, like we should, I do believe that we should work on multiple skills in ourselves to be on the safe side.
To be on the safe side, just like go all in on AI. Learn how to use it so that you already have access to all these different things that you need to learn about.
My question is more on agentic AI. So you had a picture about all the different startups building their specific agent for a specific use case. My question is more on how do you see it in the industry, specifically in big tech? Are we going to have like a tsunami that is going to replace all these startups and have just a few agents that are just great at everything?
So we're already seeing that agents need specialization. And so right now, startups are going to beat big tech companies. Big tech companies are mostly focused on being one of the layers of the abstractions. They want to be like the thing you build on top of. They're trying to build some agents, but those are generally going to be like most useful for like many people, but not useful at everything. So for example, there are now agents that just do like recruiting, or just like sales outreach, and they're already being valued at hundreds of millions of dollars. So the trend right now is like pick a problem, like a very specific problem, and go very deep on it.
Okay, so you mentioned that team structures will change, and I don't know, what her name is, but she said, no, basically people will have to be more interdisciplinary, and you said that they have to have world-class skills. So how do you think our education system will change? Do you think, coding will be more adopted as you built an app once that taught kids how to code? Like, if you were to do something like this nowadays, what would you do?
Sounds like a great Joe question, actually, for the future of education. But world class doesn't mean like your best programmer. World class also is possible when you're like someone who understands data really, really well, but you also are a designer and can weld. Like this is just a random thing. Those combination, world class, like the bar for world class is not like, Ronaldo level, because there aren't that many people. So world class can be much more accessible. But there's in terms of what we should teach people, like if you love math and you learn math, you become super good at it, you're also going to learn other things that are very useful, like the way you think is going to be very different and useful as well. So I don't have a real clear question, but one thing that is very clear to me is that you don't have to rely on going to a room with a human in front of you, like me, or a professor, to bestow knowledge on you. Knowledge and expertise, even like world-class knowledge and expertise, is going to be available to everyone in their pockets. And so it's really, we're living in a moment where it's going to democratize access to knowledge to so many people all over the world. And that's exciting.
So you think that even educators might get replaced?
So educator is not just like the words coming out of their mouths, right? Educators do so much more.
Yes,
The
exactly.
humans, as humans, we value and we care about. But if a teacher shows up and just like blurts some knowledge, gives you a PDF and leaves, I think that's doing a disservice.
Thank you for the great presentation. Even though I wasn't like half of it, I wasn't even here. But if AI for like big companies, including food industries and technology industries, do you think they'll lose money if their AI stops working?
Yes, that's the easiest question. So thank you.
You said more prompting is better than fine-tuning at some point, right?
More prompting is better than?
Fine-tuning the model at some point.
Most of the time.
Most of the time, yes.
And you should prompt first.
This means that you have some weights that are being not used in the pre-trained model.
So maybe help me understand your question a bit more. What are you looking for exactly?
Computational downfall of relying more on prompting than fine-tuning.
So fine-tuning is very useful if you want a very specific structured output, or you want to use less tokens, or you want to have lower latency. It's not good for more knowledge or more skills. People think it's like you can teach it SQL. No, like you can get an existing LLM to do better SQL responses if you just give it more examples, or you use a reasoning one, or you do few shot context learning. You don't need fine-tuning fine-tuning is not good for those type of things. So if you want to, for example, in your case, be more efficient, whether that's latency or cost, fine-tuning makes sense. But you can also probably also optimize via prompts as well.
I want to know what your experience is like in responsible AI. How at Amazon or at any other company do they restrict LLMs from doing dangerous things? And how will that continue to agents? Because agents are much more capable of doing things.
So all companies, especially big ones, are very, very strict on what you can use LLMs for or AI applications for and what you can't use them for. There's approvals processes and things like that. The good news is also that the popular models are post-trained in a way that they kind of are already safe out of the box a lot of the time. What I did find is that there's also a trade-off between trying to make it safer yourself and the performance. Like once you start trying to tune it down, whether by giving it a lot of negative statements in the system prompt, don't do this, don't do that, or use guardrails or stuff like that, you actually see performance go down. And so whenever possible, my advice is to try to use, this is just practical stuff, just try to use like AWS Comprehend or things like that to make it safer without impacting the underlying performance. But in terms of responsible AI, there's a lot of research and a lot of work going on, and it matters a lot for the frontier labs, especially the Western ones. For the non-Western ones, it seems censorship is kind of more important, which is another form of safety that matters to them.
Right now, when applying to as students, when applying to for internships or for jobs, one of the most important thing they ask for is AI knowledge or experience. And but when we look at AI, it's a very wide field and a very big one. So what would you say is some experience in AI that is more important for us to learn than others for students?
Build an AI application yourself, and you'll learn everything you need.
Build an AI, a functional AI, like an LLM,
like use OpenAI's APIs to build some translation app, or an app that makes jokes, or make an agent for you and your friends to give you responses to your exam or something. Like build something useful for you, and that process you'll learn everything these people actually mean with AI experience.
Okay, thank you.
Because the secret is they don't know what AI experience actually is.
My question is related to building scalable AI models and not involving humans in the loop. Currently, given that most AI models and ChatGPT, they still suffer from hallucinations and so on, is it are we already at a stage that we can say we can build scalable AI models without the need of humans that could or they need to evaluate these outcomes and assess them?
Just to check I understood your question. Are we at a stage where we can scale AI application without needing humans in the loop?
Exactly.
Yes, and we're also further ahead than we think. For example, there's already research papers coming out and new domains of science that are coming out, like mechanistic interpretability, where they actually are showing that LLMs fire up a certain pattern when they know that they're hallucinating. So we're already at a stage that we know when an LLM is hallucinating versus not. And so I'm going to expect this hallucination problem to be, it already is, not as big of a deal, but it's going to become less and less of a deal. But no matter what, like these are non-deterministic systems or probabilistic systems, and engineers are very good at building deterministic systems on top of non-deterministic things. And this is, so people need to kind of change their paradigm into thinking that this is a different world where you have to accept that it's non-deterministic, and you build a system or you design a system around those things, and you use evals to measure them and reduce them over time.
Last question.
Hi, thank you. I want to ask about the protection of data of people while using AI models, because it's a subject that we heard a lot about, but there is definitely progress in it. So I want to see if there's any development, anything about it.
So what matters is actually who's offering you this application. And so if you're using free ChatGPT, part of their terms of service is they're going to use everything to improve their service. If you're using Microsoft Copilot via some enterprise agreement for some company, in that agreement is that they will not use your data. And there's a lot of applications, even the ones that I've built, where no one sees the data that's coming out in and out of inferencing with the model. And so unfortunately, my personal perception is that data safety and protection is an overhyped problem by people who don't actually know the technology very well to be able to sell like consulting services and that kind of stuff. Like it's like hallucinations, data security, and those type of things were concerning in 2023, maybe for a bit, but they're not as concerning now as they were before. Cool. Thank you guys so much and for the really awesome questions. Have a nice day.